Hello students, and welcome to our lesson on algebra review. The first thing we're going to do is multiply what we call some special products. If you look at what we have here, these are called conjugates, right? Conjugates differ by the sign of the second term. Okay, so if we have a plus b times a minus b, if you look at your inners and outers, they're opposites. So they cancel out, and we're left with a squared minus b squared, which is called a difference of squares, a difference of perfect squares. So when I see that I have binomials that are conjugates, I know that I can multiply just the first terms and the last, and disregard the inners and outers because they'll always be opposites and drop out. So there's my product. If I have a binomial that I'm squaring, this is a different pattern. If I have a minus b quantity squared, that's equal to a squared minus 2ab plus b squared. Right? If I were to expand this, which you want to learn the shortcut, but if I do it the long way, then I would do FOIL, so first terms, outers are minus AB, inners are minus AB, and then the last terms are b squared. The inners and outers are the same, so I get twice their product. If this were a plus, the only difference is that now in the middle I would have plus 2ab. So when I have p minus 1 squared, I know that my first term is p squared, minus p gives me minus 2p, and then plus 1. 1 times 1 is 1. So there's the product for p minus 1 squared. Okay, let's move on to solving systems. So here you're given the choice of substitution or elimination. When I look at this system, I want to use elimination because it's perfect if I have opposite coefficients of any variable. I don't have opposites, I've got the same, but I can easily change that by multiplying by a -1. So I'm going to multiply this one by -1, which means that I will just change all of the signs, and I like to circle my new sign. So that becomes a plus, this one becomes a minus, this one becomes a plus. And then I add my two equations together, and now I have opposites, so the 6x's reduce out. I have 6y minus 3y, so that's 3y, and then 18. So y is equal to 6. So that's my y value, and now I can go back to either equation, the original or the changed version, it doesn't matter which one. So any of those three, I can plug in 6 and solve for x. Okay, so go back and try that. Plug in 6 and plug in 6 for y and solve for x. Okay, in this equation, I'm going to choose substitution because I have this y with a coefficient of 1, so I can easily solve for y. So from this equation, I know that y is equal to 9 minus 5x. So I'm going to replace the y in the second equation with 9 minus 5x. So my new equation is 10x minus 7 times 9 minus 5x equals -18. So I have 10x minus 63 plus 35x equals -18. When I add my like terms, I get 45x, and then I'm going to add the 63 to the other side, and that gives me a positive 45, so x is equal to 1. So now again, I can go back to any of these equations, this one's probably the best, plug in for x, and solve for y. So go ahead and do that now. Okay, so let's check and make sure that you've got the same solutions. And remember, you can always check your systems by plugging your values into both the original equations and checking to see if they make sense. Okay, so you can always check these types of problems. Let's take a look at a couple more, because now if I'm going to solve by elimination, sometimes I need to multiply by another value. So here, when I look at this, I see the minus 3x and the minus 9x. If I take the first equation and multiply by negative 3, that will give me a positive 9x minus 21y and positive 48. So every term gets multiplied by that negative 3 on both sides of the equation. So now when I combine, the x's drop out. I get negative 16y is equal to 64. Or I'm sorry. Yeah, that's right, 64. So y is equal to negative 4. So go back and plug this in and solve for x. Again, you can use any of the 3 equations you see here. Okay, the last one. Sometimes when we have to solve by elimination, we need to multiply both equations. So in this case, I'm going to work with the x's. Okay, because I notice I can get 32 from 16 and I can get 32 from 8. So if I multiply the first equation by 2 and I multiply the second equation by 4, I've already got the opposites. Right? I've got a positive and a negative. So that will give me opposites. And then I can solve, that will cancel these out. I can solve for y and then go back and plug the y in and solve for x. So go ahead and try that now. And when you're done, come back and we'll compare solutions. Okay, let's see how you did. So again, check and make sure you've got the same values. And keep in mind again that you can always check these equations by plugging your values into both of the originals. Okay, so I hope you enjoyed this review of solving systems and multiplying out binomials and difference of squares. And if you have any questions, let me know in class. So go ahead and finish the rest of the problems, and you can show me your work in class. Have a good day.